This problem and all other CALC 152 problems can be found here at Sarai Studies. Link is in the description box below. This is a visualization for squeeze theorem. So let's say that you're on the highway and there's 3 lanes and this is your car, you're on the middle lane. And then you are in between 2 cars. And let's say that these cars, for the entire time that you're on the highway, are always next to you. They do not move. And not only that, but they're going to the same place. So since they're going to the same place and you are between them, you're going to be forced to go to that same place as well. Because it's not like you can go to the left or the right because they're blocking you. So if you have a function f of x, and if you can find 2 functions, one that's smaller and one that's bigger than your f of x, and these 2 functions are being limited to the same value, they're going to the same place, you can conclude by the squeeze theorem that your function will have the same limits as these because it's squeezed between those 2. So let's say that you have this sequence and you're trying to find if it converges or not, then you can take the limit of it. And then you would be like, well, I know that sine of any value will always be between -1 and 1. Because if you graph sine, I know that sine always starts here because sine of 0, if you plot 0, sine is 0. So you know it starts there. So it oscillates like this, but it oscillates between 1 and -1. So I have this fact, but it's not really useful to me because what I want in between is this. So I just asked myself, how can I get this to look like this? Well, I would just have to add whatever's missing, and that's the division by n. But whatever I do to one side, I have to do to all of them. And so then now I have the same things. You're just dividing by the same thing. It's still going to be proportionally the same. And now you have your function f of x in between, or in this case f of n, and then you have -1 over n on the left, and you have +1 over n on the right. And so now you want to find out where the red car, the red function is being limited to, and you want to find out where the blue car is being limited to. And if the limits are the same, if they're both going in the same directions, then that must mean that the middle function, the black car, is going to have to be going the same place. It's going to have to be limited to the same place because it's squeezed between these 2 functions and it can't get out. So it's going to have to be forced to follow where they're both going. So here we have, if the limit of the red car is equal to the limit of the blue car is equal to some limit, then the limit of the black car, the one in between, is going to be forced to be equal to that same limit. It's going to be forced to be limited to the same place that these 2 are going. So then I would just have to find the limit of the red function. And in this case, instead of x, we have our n. And when we plug in infinity, we have one whole divided into infinitely many pieces. If you keep cutting it up, the whole is going to get infinitely smaller. So small, you're just not going to see it. It's going to be 0. And the negative doesn't matter. I mean, -0 is still 0. And then same thing here. You have 1 over infinity. You take one whole divided into infinitely many pieces. The whole is going to get smaller. So small, it becomes 0. So now, since the limit of this is 0, and the limit of this is 0, and this function is stuck in between these, and both of these are going to 0, what do you think that means for the function in between? It's also going to have to go to 0. It's squeezed between these 2 cars, so it has to follow where they're going. If they're both going in the same direction, the black car is going to be forced to go in that same direction. So by the squeeze theorem, we can conclude that the limit of our function is equal to 0. Hence, the sequence converges to 0, and that's it for this video. I'll see you in the next.